14 participants. Yes, I will be uploading yesterday's lecture on LMS just after this lecture. Yesterday there were some issues with the Google network, everything was down, so could not do anything. And meanwhile, most of you are asking, you have not got your responses of quiz. So that was also due to the Gmail issue. The mails were not being sent in bulk. So today we'll give a try once more. Otherwise, we'll release your marks individually. For the time being, the answers have been uploaded on LMS. You can see the quiz one answers are there along obviously with the questions, and their answers are there on LMS, so you can see your answers from there. And otherwise, obviously, within a day you will be informed about your scores. If they are not released via that way, we'll be finding out some way to tell your individual scores, right? So right now I'm going to start with lecture. Okay, so today we have to start the topic of the chapter of multiple integrals. So this is a chapter number 13 of your Thomas and Finney ninth edition book. So this is chapter number 13 in that. So before introducing you to the multiple integral, let me recall you the single integral, and specifically we are interested in definite integrals. So if you are given a function of one variable x, and then you have to integrate it, so this is the usual notation, that's how we integrate fx dx. And if I give you even the limits, upper limit and the lower limit, so this a is called the lower limit and this b is called the upper limit, then this type of integral is known as a definite integral, because you have given finite limits. Both a and b are finite. So when both a and b are finite numbers, real numbers obviously, because we are dealing with the functions of variables which belong in real domain. So if a b are finite, we call this definite integral. So what is the geometrical meaning of definite integral? If you can tell, I hope you must be knowing this. Just like everything has a geometrical significance, the derivative has a geometrical significance, that it tells us the rate of change at a particular point. So it's a slope of the tangent at that particular point. So what is the geometrical meaning of this definite integral? Yes, this is the area under the curve actually. So you will be in one dimension, so this is your x, this is your variable. So when you would be plotting your function y is equal to fx, this side it's y-axis. So whatever the kind of function you have, whatever the curve you have, so say this is fx, and there are 2 points, x is equal to a and x is equal to b. So because you are within these limits, so you take the image of these points. So this point becomes a comma f of a, and this point becomes b comma f of b. So this one, the area enclosed between the lines x is equal to a and x is equal to b, and below the curve y is equal to fx, right? So between the lines x is equal to a and x equals to b, and below the curve y is equal to fx, this area is nothing but the value of this definite integral a to b fx dx. So that is the geometrical meaning of this definite integral. I hope that is clear to everybody, because this we have studied in our earlier classes in the basic calculus. So have you ever wondered why this is area, how this is area, like who invented this, that why this area is representing the value of this integral? So I'll be just giving you a very brief intuitive idea from here. Actually what happens, suppose you want to measure this area, the this which I have shaded. So essentially what you are going to do, you're going to partition your domain, the interval a to b, in small sub intervals, say something like this. So depending upon the length of the interval and depending upon this length of the small interval which you have chosen, so you will be drawing your rectangles. So this is just for understanding. So you just understand it. Don't try to note it down. This is all there in the notes and the book, right? So when you will be drawing the rectangles, so that means with this point, if you take its image, so you will get something. So this 2 points you join, you'll get a rectangle. And then again, you mark this one, so you will get to join these points, and then you will get to mark this one. So again you join, so you'll get these points. So similarly, so you keep on doing this. You take their images and then you join the consecutive points. So obviously you are going to get the rectangles in this way. Otherwise they are not rectangles because the curve is like this. If you simply join this, this is not a rectangle. This is having a different shape because of this curved side. So what we are going to do, make this a rectangle by drawing the line in a way so that it becomes a rectangle. And similarly, or you keep on doing this, sorry, it has to be a straight line. So what happens? So then you start measuring the areas of the rectangles, because everybody knows the formula of the rectangles, right? How to measure the area of a rectangle, everybody knows that. So then you add all the areas of the rectangles, and that is the approximate area under the curve, right? So this is a way, this is a rough way that suppose you do not have any way to measure that area. So what will be the crude and what will be the basic technique which will be used to measure that area is you will start making rectangles like this by dividing your domain in sub intervals, and then you just add the areas of all the rectangles, and that will be the approximate area. So this integral a to b fx dx is actually approximately equal to, okay, so what is the area of one particular rectangle? So if you divide these points, so these are say x naught, x1, x2 up to xn. Suppose you have n intervals and these are n plus 1 points. So suppose you start from x naught. So this is x1, x2, x3. So the last one is xn, the first one is x naught. So what is the area of this particular rectangle if I ask you the first one, right? So this is, suppose this interval, the length of this small interval is delta x. The division which you have done, suppose that is delta x. So this is delta x because that's how the area of the rectangle is measured. It's length into breadth. So this is the length, this is a breadth. So length is decided by what is this value, like f of a. So this is basically f of x naught. So f of x naught into delta x. Suppose all of the lengths of these intervals are equal, delta x. So this will be the area of first rectangle. I hope this is clear because this is a rectangle. I can see this is the breadth, delta x, and this is the height. Plus, similarly, the next rectangle area will be fx1, because in that case we are measuring the height by taking the image of x1, and so on. You keep on doing this fx and delta x. So this is the sum of the areas of all the rectangles. This is approximately equal to this, right? So you can see that when this approximation is going to be a good approximation, if delta x is small, if you choose this interval to be very very small, in that case this is going to be a good approximation. I will be just explaining you like this here. Again, you just take an example. Say this is your curve and this is my a and this is my b. Suppose I just take one interval. Suppose I take n is 1, so there are just 2 points, x naught and x1. So this total is my delta x. That means I am taking delta x quite large, as you can see. So in that case, if I use a rectangle technique, so this will be my rectangle, this will be the rectangle. So the area of the rectangle will be this complete, while my actual area of under curve is just this one. So that means this part is the error part, the difference. So it's not a good approximation because there is a error is huge. You can see the area of rectangle is quite bigger than the actual area under the curve. So if you will be writing that this is approximately equal to this fx naught into delta x, where delta x is obviously this length of this interval, which is actually b minus a. So that means this is a very poor approximation because you have just considered one rectangle. Similarly, now I take two rectangles, means I make delta x half, I take one more point, x naught, x1, x2. In that case, my approximation will be better. So this is just an intuitive way to understand. You start doing this. The smaller the length of delta x, the better is your approximation. As you can see from here, there will be very, very small extra areas. So these extra areas are just going to be the errors. So smaller the delta x, better is approximation. That is why the actual formula is a to b fx dx is limit delta x going to 0, summation fxi into delta x, I is from 0 to n. So ये summation is for this. Delta x, as you can see, is common, so that can be taken common. And this is fx naught, fx1, fxn. So that is fxi. I denotes these points, right? X naught, x1, x2. So I have written this is in precise form, the summation form. And since delta x should be as small as possible, only then this is going to be approximately equal the actual area. So therefore, this limit is introduced, that limit delta x should be 0. Right, so this is the basic introduction you will be finding in book. We are definitely not going to use this anywhere throughout the chapter, but this is something you should know. This is the fundamental, that how the area under the curve is actually giving you this the value of the definite integral. So this is how integrals are approximated. And now similar concept will be generalized to function of two variables, right? So in function of two variables, what happens? यहाँ पे तो आपका domain was just x, just one line, and this side we had y. So when you will be moving towards function of two variables, in that way, in that case, your domain is going to be a plane xy itself. So you have this x and y. So this is your 2D domain, two-dimensional domain, which is your plane. Remember, I have not used the third axis. I have not drawn the function z is equal to fxy. I'm just explaining what you are going to do with the domain. So in this case, since you have two variables in your domain, so both of them will have their limits. I told you this yesterday, that this is what the meaning of the double integral is going to be, that you have to integrate the function of two variables two times, one time with respect to x and one time with respect to y. So your limits are going to be here a to b and c to d. So there will be two limits, two lower limits, two upper limits. So I will be explaining you that how to read this कि a b किसकी limits है और c d किसकी limits है. So it's easy to see because the order matters. ये किस order में लिखा है? It is dx dy. So जो variable पहले लिखा है, so that means the first integration has to be done with respect to x. So that means the inner limits जो पहली limits हैं from inside, they are of the first variable. So this is how you treat this. This is something like, firstly you will integrate with respect to x, then you will substitute a and b for x. So since it's a function of two variables, so when you will be integrating with respect to x and substituting a and b for x, what you will be left is only a function of y, and then you integrate with respect to y, and finally you substitute limits c and d. So this also going to be a numerical value, right? Because it's a definite integral, it will not be a function. You have substituted the value of the variables, but what is this numerical value and how you have to compute this? So this is how you have to compute. I will be explaining this with the examples, obviously. Then you will be very much clear that what is the meaning of dx dy. That first with respect to x, these are the limits of x. Then with respect to y, so these are the limits of y. So x lies from a and b. So there will be line x is equal to a and x is equal to b. So x is equal to a and x equals to b, something like this. And then similarly, y is equal to c and y is equal to d. So this is going to be your domain. So this is the simplest example of the drawing the regions, this domain is called a rectangular domain. When both x and y are having these values, so you'll always get a square or rectangular type of regions. So like A, B, C and D. So this is your domain, right? Just like you had domain here A to B. So what we did to find the area, we approximated, we divide the domain into small intervals. तो आपने AB line के intervals बना लिए थे, right? Each interval was of having specific length, which was delta x. The same thing you will be doing here. So you will be drawing the sub intervals of your rectangular domain. So actually we will be creating a mesh. This is called a mesh. We are dividing both AB means both in x direction as well as in y direction. So x side पे भी आप break कर रहे हो उसको small intervals में, right? और y side पे भी you are creating the interval. So on y side, this, so if you consider this particular rectangle, so this is delta x and this is delta y, right? If you consider a particular rectangle, so the length of this rectangle, this side is delta x and this side it is delta y, right? So this is how you deal with the domain. So on the similar lines, the way we write this formula, on the similar lines, you will have the formula here that this fxy dx dy ab cd is approximately equal to, right? But when we write in the limit form, so we can write exactly equals to. So here there was limit delta x going to 0. Just a moment. But here now what is going to happen? Limit delta x goes to 0 and limit delta y goes to 0. Obviously the function values fxi yi multiplied by delta x into delta y, right? So that is how we write the approximate value of the definite integral. So this is on the similar lines. यहाँ पे बस दो variables हैं, delta x, delta y. तो both of them has to be, means the smaller this rectangle area, better is your approximation. Okay, so now you can tell me what is the geometrical meaning of double integral. So this is a double integral because we are doing it two times. The single definite integral was representing area. So what this double integral is going to represent? It's definitely going to represent the volume, right? Because yeah, you are jumping one dimension higher. एरिया तो यहाँ पे आपका डायमेंशन में ही है, 2D में ही एरिया बन गया है. इफ यू सी, सो व्हेन यू वांट टू टेक द इमेज ऑफ इट, सो दैट विल बी representing the domain volume. I'll be just sharing a file with you and then I will be explaining that how this is representing the volume. Anyways, you don't need to remember these formulas. This is just to understand how we say that this is the volume and how we say that this is the area. So you just need to remember that this one dimension represent, in one dimension we have the area and in two dimension we have the volume. Just give me 1 minute, I'll be back. Why my laptop? Okay, just let me open a file. Lecture. Okay, I'll be just explaining you like this. I did not have that file in my system. So anyways, I can explain you how that is representing volume. So what is happening? This now I'm going to draw the 3D version of it, because only that way you will be able to understand its volume representation. So this is XY plane, and on this side you will be have the Z. So in XY plane, this is your domain. So these are the lines. X is equal to A. Um, sorry, this is the x-axis. Sorry, this is y is equal to C, and y is equal to D, because if on x-axis if you draw, so the y is constant in that case, and in this side if you will be drawing, so x is having some constant value. So x is equal to A and x is equal to B. So this area is your domain, and if you have a surface looks like z is equal to fxy, so you take the image of points these points 4 points, and then whatever you get, so this surface you get image. So this is a 3D solid which you will be manufacturing, so that is the volume. So whatever 3D object will be arising out of it when you will be taking the image of your domain onto the surface, and so it will generate a volume. So it can be a cube, it can be a cuboid, depending upon how your function is defined. So whatever is this underlying volume, that is given by the value of the definite integral fxy dx dy, right? So this is also explained in my notes that this S is the surface. So the surface, below the surface, whatever is this object created, so that represents the volume. So that is all about the geometrical interpretation. Now we are moving ahead towards actually what we have to do to evaluate this kind of integral. So you will be given the questions like evaluate the value of this integral, or you will be asked that volume, you have to find the volumes and other things, right? So this is fxy dx dy. I explained you how you have to read this integral. So if dx is written first, so these are the limits of x. If then dy is written, so obviously these are the limits of y. So let's just do one question, so it will be very much clear to you that how we have to solve this. So compute this integral z dx dy over r, where r is the region x lies from 0 to 2 and y lies from 0 to 1 in xy plane. So you are given r as a region. So this is one way of looking at the questions. You will be given questions like this, in which you are given x and y individual limits, and you have to evaluate the integrals, and you're also given the value of z. So z is 4 minus x minus y. So you need to evaluate this integral dx dy. Now since dx is written here, so the inner limits will be from x. So x lies from 0 to 2. So x lies from 0 to 2, and dy is written outside. So the outer limits of y, so that is from 0 to 1. So all what you have to do is evaluate this integral. So I have told you, first you have to integrate with respect to x in this function. So how you have to integrate with respect to x? So because it's a function of two variables, so you have to keep y constant. So you integrate with respect to x by keeping y as constant, and then let's see what you get. So this is 0 to 1. So tell me the value of this integral. 4 minus x minus y, with respect to x you have to integrate. So this way you will be getting 4x minus x square by 2 minus xy, because y is also a constant for x. So it will be x into y, it will be 4x. So that is what the inner integral is. Now you have already integrated with respect to x. So you will be substituting the limits 0 to 2, and this 0 to 2 limits will be substituted for x. Y will remain as y. You have to substitute for x. So you just do this substitution and then see what do you get. So this outer integral remains same. So this is 4 into 2, 8 minus 4 by 2 minus 2y. And when you will be substituting 0 for x, so these all terms will be 0. So this is dy. So this is 8 minus 2, 6 minus 2y into dy. So that's what I told you. Ki when you will be solving the inner integral, whatever you will be left with is just another variable, because x to eliminate ho gaya hai, so you are just left with another variable y. So this is 6 minus 2y. Now it's function of just one variable, so all of you know how to do the integration. So this is 6y minus 2y square by 2, 0 to 1. So 6y minus y square, 0 to 1. So 6 minus 1, which is 5. So that is the value of this integral. So that's a easy question which you saw, that all what you have to do is to find the value of this integral. Now I'm just giving you one more, the same question you have to do. You change the order. 4 minus x minus y is the function. First you integrate with respect to y and then with respect to x. Obviously limits भी change हो जाएंगी. Inner limits जो हैं y की हैं और outer limits x की हैं. So in y की limits है 0 to 1, x की limits है 0 to 2. So I've changed the order. So you just solve on the similar lines and tell me the answer. Yes, all of you solve this one. Yes. What is the answer to this question? So this is still 5. You will be getting the same answer. That is what my point of conveying this was, that you will be getting the same answer. So that means whenever you change the order of integration, so whatever is this function, this is obviously fxy. So this is your fxy. So if you change the order of the integration, still you are getting the same answer. So this, that means if I want to draw a conclusion out of this, so fxy dx dy. So this is same, whichever order you did, dy dx or dx dy. So this is say a b c d, and this is obviously a b c d, where x lies from a to b and y lies from c to d. So this you can try on any of the example and you will find that they are same. But here is an important point: they are coming out to be same only because the underlying domain is a rectangular domain. So I hope you understand the meaning of the rectangular domain. So I just told you what do you mean by rectangular domain, that whenever you have x and y are having the constant values. So what kind of domain it is? As you can see, if you draw this in xy plane, so this is x is equal to a, x is equal to b, and this is y is equal to c, y is equal to d. So your underlying domain is a rectangle. Only in that case, this order is not going to matter. That means x is also having constant values. X is lying between two constant limits and y is lying between two constant limits. Only in that case, these two integrals are going to match. So this is actually a theorem. So this theorem is Fibonacci's theorem. That is the name of this theorem. So this tells you, the statement of the theorem tells you, if fxy is continuous on a rectangular domain or rectangular region, you can say R. And how does a rectangular region looks like? X lies between A and B and Y lies between C and D. So they are both constants. A, B, C, D are all constants. Then in that case, the value of this integral is equal to this. Let me finish the statement, then I will be explaining this. So this I have just told you, x a to b, ये x लिखा है, so y की लिमिट्स आउटर होंगी, यहाँ पे y लिखा है, so y की लिमिट्स इनर होंगी और x की लिमिट्स बाहर होंगी. बट जब आपको कॉम्बिनेशन में लिखना होता है, सपोज यू जस्ट वांट टू राइट लाइक ओवर द रीजन r, you don't want to specify the individual limits. In that case, फिर हम यहाँ पे dx dy नहीं लिखते हैं, we write dA, where dA represents the area. So the small rectangle which you consider, so this is dx, this is dy. So the area of this rectangle is dA. So that is just for theoretical way of writing, but actual mein we know in questions we have to write in this order. So this is Fibonacci's first theorem, which tells you that over the rectangular domains, the value of these integrals are same in whichever order you integrate, either first with respect to x or first with respect to y. Obviously, you have to take care of the limits. In that case, this is going to be equal, right? So this particular integral is having a name. These integrals, which I'm just telling you, these are also known as iterated integrals because you're solving in steps, you're solving in iterations. Iteration means the same thing you have to repeat again and again. So in first iteration, you are solving with respect to x. In second iteration, you are doing integration with respect to another variable. So this is also known as iterated integral or repeated integral. This vocabulary I'm just telling you because in case in books you find this written, so you should not get confused but that what exactly this is. So this is what we have so far for this kind of example. So now you can try this over any of the example, right? In your book, you will be finding plenty of examples when your domains are rectangular domains. So what is the way to identify rectangular domains? That all these four values, lower and upper limits, they are constants. Constant means x also lies between two horizontal lines and y values lies between two vertical lines. Sorry, I'm saying opposite. X values lies between two vertical, y lies between two horizontal lines. So your domain is always a rectangular one, right? So moving ahead towards the next question. So it's on the similar lines. So let's do this question. Sketch the region of integration. I told you this thing in the last chapter also, that in this throughout this chapter, multiple integrals, you will be asked to draw the regions of integration and do the calculation. So make it a habit, you sketch the region of integration. In previous question, we did not do that. It was easy. In this question, if you want to sketch the region, so it's easy. X lies from 0 to 2 and y lies from 0 to 1. So x lies from 0 to 2 means x is equal to 0, x is equal to 2, and this is y is equal to 0 and y is equal to 1. So in the previous question, if you had to sketch the region of integration, so this would have been the region of integration. Now let's do in this question. So the region they are telling is 0 to 3 minus 2 to 0 x square y minus 2xy dy dx. So there will be two kind of questions you can see. In the previous question, they told you the limits, they told you the wording, they define the region in words and then you had to translate that to the limits. यहाँ पे डायरेक्टली लिमिट्स गिवन है आपको, मींस इंटीग्रल गिवन है, आपको लिमिट्स से रीड करना है कि रीजन क्या होगा, राइट? सो यू हैव टू स्केच द रीजन ऑफ इंटीग्रेशन एंड ऑब्वियसली solve the value of this integral. So how will you identify what kind of domain this is? Since you can see all of these are having constant limits, all four limits are the constant limits, so definitely it's a rectangular domain. But you just need to know which are which, x की कौन सी limits हैं और y की कौन सी limits हैं. So how we are going to identify that? So you look at this. It's y written in the first place. So that means जो inner limits हैं वो y की हैं और outer limits जो हैं x की हैं. So it's very easy to read it like that. You just read it from the order. I hope it is clear. Previous question में उन्होंने explicitly बताया था कि x lies from 0 to 2, y lies from 0 to 1. So it's very easy to draw the regions in this case, right? But in this question, they have not stated explicitly, rather they have given directly the value of the integral. So in that case, we have to read the integral and understand ourselves where is x and where is y. So since inner variable is the first variable is y, so the inner limits are of y. So that means y lies from -2 to 0, -2 to 0, and outer limits are of x. So x lies from 0 to 3. So now you draw this region. Obviously, it's a rectangular one. So x lies from 0 to 3. So x is equal to 0, x is equal to 3, and y lies from -2 to 0. So you have to draw two lines, one at y is equal to 0, one at y is equal to -2. So y is equal to 0, we already know this is our x-axis, and -2 will be beyond this. So this is your region of integration. So since they are asking to sketch it, so you explicitly need to shade that region to show that this is my region of integration. They will never ask you to draw the 3D diagrams of the function itself. This has nothing to do in the drawing. The drawing has to be purely from looking at the x and y values, because we are not going to draw 3D figures. This function is always z, which is function of x and y. This will play role only in the calculation of the integral. जब आप integral को solve करोगे, this plays no role in looking in drawing the regions of integration, right? I hope this is clear. So this question had two parts: sketch the region and solve the integral. So we have sketched the region. Now you just need to solve the integral. So all of you know how to solve it. So firstly, you will be integrating with respect to y, because this is the way they have given you. They will be solving with respect to y, substitute the y limits, and then solve with respect to x, right? And in this question, it will not matter whether you first integrate with respect to x or y, because the underlying region of integration is a rectangular domain, right? So if you change the order of integration, still you are going to get the same answer, but never forget to change the limits order also. That if you deliberately change the order of integration, you also need to change the order of the limits in that case, right? So you solve this one and tell me the value, what you are getting. Yes, fxy is continuous. That condition will be default satisfied. It's a part of the theorem, but these functions are always continuous functions, because the kind of functions you will be getting here are the polynomials or uh, exponential trigonometric, so they will be continuous. So you solve this integral, you will get the value to be 0. It's very easy to solve the integral. So this is the usual practice which we will be adopting in this particular chapter. That important point will be these: drawing the regions accurately and doing the calculations. But once it is like you just need to do the integration, so that part will be left upon you. So if anybody of you thinks you are not good at integration, so you practice that first, because this chapter is all about solving integrals. Okay, so the final answer is 0. So those who are getting it is right. Those who have not got it, they can try doing the calculation. So I can quickly tell you when you will be doing with respect to y. So this will be x square y square by 2 minus 2x y square by 2. And then limits will be -2 to 0 dx. And now when we'll be putting y 0, then this will be 0. When you'll be putting y -2, so you see it will be some value over here. So it will be -2x square plus 4x dx 0 to 3. So now it's just a function of one variable. You integrate this, so you'll get the answer to be 0. Right? So I hope everybody is getting that. So this was all about these two kind of questions in which you are given rectangular domains. That is, both x and y are having constant limits. 0 to 2, 1 to 3, minus 2 to 4, wherever it can be, but all of them are constant. So in that case, whichever order you solve, you will get the same answer. So next lecture onwards, we will be looking at the cases. What if the underlying region of integration is a non-rectangular region? Non-rectangular means, so you will have examples ki non-rectangular means kis tarah ka ho sakta hai. So we'll have theorems accordingly, all that. Yes, regarding the quiz questions, I have told you the answers have been uploaded on LMS. Due to Google issue, we could not send emails yesterday. Today we'll try one more time to send you the responses. If that is not possible, then we will tell you your individual scores. Right? Well, I have to talk to the coordinator what should be the next course of action, because at this point of time it was just we need to release the scores, but due to some technical issue from Google, it's not working. It has not been working. The mails are being undelivered. Few mails have been delivered, but many of them are undelivered. Tanmay, which question answer is wrong today? Which question? Quiz questions you're talking about? First answer is wrong. I have to look at that because I don't know, because everybody's order of question was different. So I have to look at which is the first question. So if you're referring to the order on the LMS, so I'll go on LMS and check that. I'll go on LMS and check that whether it is wrong or I really do not think so. It will be wrong because it has been verified many times, but still I'll definitely look at it. If you are saying this is wrong, we'll check it. Yes, Uday. You want?
वो जो डबल इंटीग्रल एफ एक्स वाई डी ए किया था मैम, उसके अंदर मैम अगर एक ही डी बच रहा है फिर मैम, तो फिर एक बार इंटीग्रल करके तो वो खत्म हो जाएगा, फिर मैम अगला इंटीग्रल के साथ तो कोई डी होगा नहीं.
नहीं नहीं, ये लिखने का तरीका है. ये डीए इज एक्चुअली दिस डीए इज इंडिविजुअली हैज नो मीनिंग. इट्स डीएक्स इनटू डीवाई. राइट? इट इज जस्ट जब हमें ऑर्डर को बताना नहीं होता कि पहले x है कि पहले y है, बिकॉज हमने यहाँ पे r लिखा है, हमने यहाँ लिमिट्स नहीं ना लिख रहे, तो यहाँ पे हम उसको कंबाइन करके लिख देते हैं. dx इंटू डी को dA लिखा जाता है. ऑब्वियसली सॉल्व करने के लिए हमें इस फॉर्म में ही पता होना चाहिए जब हमें एक्चुअल में सॉल्व करना है. ये सिर्फ थ्योरेटिकली लिखने के लिए होता है.
ओके मैम. और ये रिपीटेटिव मतलब क्योंकि हमने 2 बार किया इसलिए कह रहे हैं रिपीटेटिव.
इसलिए इसको रिपीटेड इंटीग्रल बोलते हैं. जैसे हम डबल इंटीग्रल इज अ रिपीटेड इंटीग्रल, इसका थर्ड डायमेंशन ट्रिपल इंटीग्रल्स भी होते हैं, बट बिकॉज यू कैन सी कि डबल इंटीग्रल में ही हमें अंडरस्टैंडिंग के लिए 2 डायमेंशन 3 डायमेंशन तक जाना पड़ता है. तो अगर अंडरलाइन वेरिएबल्स ही 3 होंगे, सो इट विल बी डिफिकल्ट टू विजुअलाइज दैट, बट यस, ट्रिपल इंटीग्रल्स एग्जिस्ट.
ओके मैम. एंड मैम वो जो ग्राफ हमें जो स्केच करना है वो हमें सिर्फ डोमेन स्केच करना है ना, फंक्शन नहीं.
Yes, you will not be asked to draw the z function because this is purely for calculation, because it's difficult for us to draw that, how that is going to look like. We are just going to draw the domain xy plane region of integration. Yes. Tan inverse n minus tan inverse n plus 1, Arjun, you are asking, the answer was minus pi by 4. This was a telescoping series. Tan inverse n minus tan inverse n plus 1. This was asked to you the sum of the series. This is the telescoping series. You will be finding the sequence of partial sums. So you will be cancelling out the terms and you will be left with only tan inverse 1 minus tan inverse n plus 1. And when you will be taking limit n tending to infinity, so this will be pi by 2. So this will be pi by 4 minus pi by 2. So this will be minus pi by 4. And everybody knows that whatever will be the limit of the sequence of partial sums, if that is finite, so the series converges. So the same number is the sum of the series. So that's why the answer was minus pi by 4 for this particular question. Right? Yeah, so I'll just go on LMS and check the answers again, and we'll try once again to release your score so that you'll get to know your answers. Otherwise, individually, we'll put up some list somewhere so that you can get to know your marks. But we need to discuss with the coordinator that what is the next course of action. Definitely, you will be told your marks, so don't worry about that. We have your marks already. Okay, so you can discuss your quiz questions, doubts in the tutorial also. Yeah, so that's all for today. Thank you. Yeah, I will be uploading these lectures today only, just right now.